So for my factoring here, first thing I'm going to do is I'm going to look for a GCF. There is none. So I can go right to parentheses. And the factors of 10 are 5 and 2. So I do 5x and 2x. The factors of 6 are 2 and 3. It doesn't make much sense to put a 2 in the parentheses with a 2x. You don't want a GCF in one of your parentheses. So this is 2 and this is 3. 15x and 4x can combine to be a 19x. So they're both plus signs. That's how I get my 19x. And once I'm there, 5x equals a negative 2, x equals negative 2/5. 2x plus 3 equals 0. 2x equals a negative 3, x equals negative 3/2. Here we take a 6 out. You're left with x squared minus 4x minus 8. Now I mess this up in the sense that there's no factors of 8 that combine to be negative 4. Okay? So this is literally where you'd have to stop at this problem, and you'd end up using quadratic formula to find your answers. I haven't gone through quadratic formula in this class, so you should have seen it before. But I'm not going to ask that on the test. What I should have made the problem, I should have made it like this. So if you want to copy this one down as another example, feel free to. If I pull a 6 out of here, I'm left with x squared minus 2x minus 8. And that can be factored. That's x minus 4, x plus 2. And then my answers of x minus 4 equals 0, x plus 2 equals 0, x equals 4, x equals a negative 2. The next two problems. I'm going to start with my 12 with 4 and 3. There's no GCF, so I can go right into the factor. My factors of 35 are 7 and 5. And I need to get to a 13. So if I do 7 here and I do 5 here, I get 28x and I get 15x. That can be combined to a positive 13 by making the 15 negative and the 28 positive. So when I do that, it's a positive 7, it's a negative 5. 4x minus 5 equals 0, 4x equals 5, x equals 5/4. 3x plus 7 equals 0, 3x equals a negative 7, x equals negative 7/3. Last one, I take a 4 out. 3x squared minus 16x plus 15. Oops. Yep. I apologize. Take a 3 out, my bad. And we're left with 4x squared minus 16x plus 15. There we go, sorry. 4 doesn't go into 45. So 3 goes into 12 4 times, 3 goes into 48 16 times, 3 goes into 45 15 times. I'm going to try 2x first. And what works out nicely here is if I break up the 15 into 5 and 3, 2x times 3 is 6x, 5 times 2 is 10x. Negative 10x and negative 6x gets me to my negative 16. And we get 2x minus 5 equals 0, 2x equals 5, x equals 5/2. 2x minus 3 equals 0, 2x equals 3, x equals 3/2. Whenever you have two perfect squares and no middle term, that basically means the middle term is 0x is the difference of two squares. It's 3x minus 8, 3x plus 8. 3x minus 8 equals 0. 3x plus 8 equals 0. 3x equals 8. X equals 8 thirds. 3x equals negative 8. X equals negative 8 thirds. Second one, I'm going to take a GCF out. All three are even numbers, so I can at least get a 2 out. When I break the factors down here, it's just 3x and x. My factors of 28 are 7 and 4 is probably my best bet. 2 and 14 and 1 and 28, I'm going to try 7 and 4. Now, let's say I did it wrong. 21x and 4x is 17x or 25x. That doesn't work. If that happens, before you move other things, change the order of your numbers. Make this 7 and this 4. 12x and 7x, that can combine to be a 5x. I make the 7 negative and the 4 positive. And that allows me to get to the correct answer. 3x minus 7 equals 0, x plus 4 equals 0. And now we solve. 3x equals 7, x equals 7 thirds. X equals a negative. Finish it up. Anytime you have two perfect squares on the outsides, a lot of times that's going to be a binomial squared. 4x times 4x is 16. 5 times 5 is 25. And then the 4x times 5, 4x times 5, 20 and 20 is 40. That can be written as 4x plus 5 squared. And that way you only have to do one. 4x equals a negative 5. And my x is negative 5 fourths. Here, with an x cubed, take the x out. And that'll give you a third answer. 2x minus 5, 2x plus 5. So x can equal 0. 2x minus 5 equals 0. Gets me to 2x equals 5. And x equals 5 halves. 2x plus 5 equals 0. Gets me to 2x equals a negative 5. And x equals negative 5 halves. And those are my answers.